Hello, this is Stylianos. I'm a physics teacher with ATS in Align, and in this video we'll solve question 2 from the 2021 AP Electromagnetism exam. Let's scroll down on the exam paper where we'll see the basic rules and geometry and calculus tips, and also the solution to part 1, which we saw in the previous video. Alright, we're here on question 2 now, and what we see is a sphere, another sphere, a balance, a string, and my guess is there will be charges, and since I see F here, probably we'll talk about the Coulomb force, so electrostatic force. Students perform an experiment in order to study the force between the two particles. Okay, I don't think that we really care about this. The electronic balance is zeroed before the lower sphere and the insulating rod are in place. Okay, so there must be a force in micronewton. What happens is that if there is a positive charge and another positive charge here, the two charges repel, and this causes a force on the insulating, this causes a force downwards, which the balance reflects as a weight, or in this case a force in micronewton. And so the students, I guess that they also measure the distance between them, so they change the distance between the two spheres, and less distance creates a stronger force. That's why when we inverse the distance to the power of 2, the force increases. Now, we need to draw a line that represents the best fit. Fair enough, that shouldn't take too long. With a ruler, we draw a line that has a few points above and approximately equal number of points below. I'm on the happy side with this. Okay, and we need to use the graph in order to calculate the charge Q. Now, let's see if we have any given values. Nothing really. So we can say that this force is K times Q1 times Q2 divided by the distance to the power of 2. Or that the force is equal K multiplied by. Since we need to find the value of the charge Q, let's see. The 2, for the first trial, a charge Q is placed on each sphere, so Q times Q, this is Q squared, multiplied by 1 over the distance to the power of 2, and we need to say that F over 1 over the distance to the power of 2 is equal to K times Q squared. So the slope of this graph will be equal to K times Q squared. So the first thing that we need to do is try to find the slope of this graph, and for this reason we'll go to the graph and find 2 points where we can see exactly the values. Now, one point in my opinion is this, and another point in my opinion is that. So the slope, which is rise over run, it is 12,000 minus 10,000 micronewton. Micro means 10 to the power of -6 divided by the run, which is approximately 75 minus 25, and 75 minus 25, okay, yes, because this is 1 over distance to the power of 2, so we have 2,000 times 10 to the power of -6, all of this divided by 50, so the answer is approximately 4 times 10 to the power of -5. This is the slope, micronewton over 1 over meter squared, so micronewton times meter squared. So we can say that 4 times 10 to the power of -5 equals 9 times 10 to the power of -9 multiplied by Q squared. So the Q will be equal 4 times 10 to the power of -5 divided by 9 times 10 to the power of actually I made a mistake. This is not -9, it is 9. And then we root the answer, which result in 6.67 times 10 to the power of -8 coulomb. Sorry for that. Again, this was not showing before. The slope we had calculated before. We replace and we place this in solver and we find the answer for the charge. Part 2 was a little bit long, but nothing really difficult. Again, after the best fit line, we need to find 2 points that represent the slope, and from this it will be easy to find our final answer. Now, on the graph on the previous page, draw a circle around the data point that was taken when the distance between the two spheres was the least. So we need the least distance. The least distance will have the greater force, or since we have here 1 over distance to the power of 2, the least distance will have the greatest value for this fraction. So this is the point with the least distance, and I think we need to draw a circle. Yes. So we're done with part 3, and we need to determine the distance at that point. So 1 over distance to the power of 2 was, the value is here. Now, this is between 12 and 13,000. Sorry, actually we need to measure the distance, so sorry for that. This is the point for the distance. It's between 80 and 100. Now, in the middle it is 90, in the middle of the middle is 85, and that point is on the middle of that, so 82.5. So the distance is root of 1 over 82.5. So this will be 1 over 9. Root 1 over 82.5. This is 1 over 9, or 0.11. And what physical quantity does the vertical intercept represent? Let's find again the diagram. The vertical intercept. Now, the vertical intercept, okay, if we consider that there is a vertical intercept, because in the previous diagram I considered that it passes through the origin. Actually, no, it's not the origin, it is 9,000, it starts from 9,000. So the vertical intercept, it's around 8,000 micronewton. Now, what does this represent? That even without any charge, the scale will show something. The scale will actually, without any distance, without any point, any attempt on my experiment, the scale will show something. And what the scale will show is the weight of the first charge. So the vertical intercept will show the weight of the charge on the scale, because this is already on the scale with or without an electrostatic force from the upper charge. So even without an electrostatic force, there is force of gravity. So this is the justification. And we continue. The experiment is extended by collecting additional data points that appear on the graph in the way that we see over there. However, we see that the new data points do not follow the linear pattern. They do not follow a straight line. And Now, there is something that causes this. We'll figure it out what this could be. The group of students tries to explain this discrepancy. One student suggests and suspects that the charge is slowly leaking from the top sphere, like the top sphere, the charge there is leaking, so the charge is reduced. If the charge is reduced, then by reducing the distance, we expect that the force will increase. And again, this was happening at the beginning. And again, yes, by reducing the distance, the charge should be the force should be increasing. Now, if the charge is leaking, so if there is less charge on the top sphere, or in one of the spheres, then yes, the value of the force decreases. And this is what we see is happening here. The expected value of the force is not happening. Instead, it is decreasing. So one student suspects that the charge is slowly leaking. This could explain, yes, because what we could say is that less charge will result in smaller value in less electrostatic force, which is what we see is happening than the expected value. And we continue to part C. A second student suspects that the excess charges have rearranged themselves, polarizing the sphere. So there is a possibility that there is a different distribution of charges on the spheres, and on the circles we need to use a plus sign on the sphere in order to represent the location of the highest concentration of positive charges. Now, we need to make sure that there was no added charge, or actually no, not necessarily, but we are talking about conducting spheres, if I'm not mistaken. Conducting spheres and conducting spheres, okay. And we're still talking about conducting spheres. Okay. All right. Maybe it would just happen. Now, since we expect, we have conducting spheres, so the positive charge tends to repel on the two spheres. So the charge is not located on the center of the spheres, but since it tends to repel, there will be more charge on the top part of the top sphere and more charge on the bottom part of the bottom sphere. So how this rearrangement could be responsible for the discrepancy? Well, since the charge is located not on the center, but on points on the top and below, then this distance increases. So the distance between the excess charge increases. And since the distance increases, then the value of the force decreases. The value of the force tends to decrease. And again, this is what we see that it is happening on the graph. And a third student now suggests that the experiment can be modified, so the top sphere is given a negative charge, that it is equal in magnitude to the positive charge. On the circles, we need to represent a single plus and a single minus, and again we have plus on the bottom sphere, minus on the top sphere, but for the same reason that the two kinds of charges are attracting, so there will be a little bit more on the top and a little bit less on the bottom. So it will show somehow like this. And we don't, okay, we need to use a single plus or a single minus. That's it. And for a separation of charges equal to that of the data point indicated on part 3, what would the magnitude of the force be greater? What would the magnitude of the force reading would be, if it would be greater, less, or the same? Now, that's a nice question. Let's see what we had before. Before we had two positive charges, that one of them was on the scale, and the reading of the scale, I don't remember how much it was, but obviously the reading of the scale was the force of gravity plus the electrostatic force. Now, for the new charges, 1 plus and 1 minus, the reading of the scale will be the force of gravity, that doesn't change, but now instead of the electrostatic force downwards, we have the attracting electrostatic force. So the total reading of the scale, the F net, or the normal force on the scale, is actually less. And we need to explain this with a few words, so somebody would write quickly that the reading of the scale is the sum, the vector sum of the force of gravity plus the electrostatic force. Before, both of them were downwards, creating a great value. Now, the electrostatic force is attractive, so it is to the opposite direction, reducing the total reading of the scale. And that was the end for part 2. I hope you enjoyed this video, and I hope that your efforts to study for your subjects are fruitful, and have a good time studying all of the subjects, and the most important of them all, which is physics. Feel free to comment your questions or any suggestions for this channel. Thank you for watching.